right, welcome to 2.2. This is inductive and deductive reasoning. All right, so we're going to go over some vocab per usual in the beginning, and then we'll get to some examples. Okay, so the first vocab word is conjecture, and that's an unproven statement based on observations. So, for example, I could say that all students in my class are 9th graders. That is an unproven statement, and it's just based on my observations that you all look small. Inductive reasoning is using a pattern of observations to write a conjecture. So, for example, if I notice that everyone, when they stand up, pushes in their chair, that would be an inductive reasoning. I'm noticing that everyone, as a pattern, that everyone stands up and pushes in their chair. A counterexample is an example that shows a conjecture is false. So, for example, if I said that I noticed that every freshman, when they stand up, pushes in their chair, and then Billy does not push in his chair, that would be my counterexample. Deductive reasoning is using facts, definitions, laws, and properties to form a conjecture. So for this one, a deductive reasoning would be that when I take two even numbers and add them, the sum of two even numbers will add to another even number. So that I could use properties and laws and stuff like that to form that conjecture. The next two on here are law of detachment and law of syllogism. We're skipping those for this unit because we're a little bit behind, so just write skip on those. All right, now we're going to go and we're going to start our examples from 2.2, inductive and deductive reasoning. All right, so let's do example 1. Write a conjecture that describes the pattern in each sequence. Then use your conjecture to find the next item. All right, so looking here, we've got -4, -1, 2, 5, and 8. Well, from -4 to -1, I added 3. Same thing from -1 to 2, add 3. 2 to 5, add 3. So my conjecture is going to be you add 5 or add 3 to the previous number. Okay, which means the next number in my sequence is going to be 8 plus 3. It's going to be 11. All right, let's look at this one here. -2 to 4. Well, I multiplied that by -2. From 4 to -8, I again multiplied by -2. 8 to 16, multiplied by -2. So I believe my pattern here is that I am multiplying the previous number by 2, -2. Multiply the previous number by -2. Okay, which means -32 times -2 is going to give me a positive 64. All right. Example 2. A student makes the following conjecture. Find a counterexample to disprove these conjectures. So starting off with example 2, we know both of these are going to be false. So now we have to find our counterexample that says why they're false. So it says angle ABC and angle CBD form a linear pair. So let's draw that, what that would look like here. So I'm going to put A here. B goes right there in the middle. And then here's going to be my C. And then C, B, and D. Perfect. Okay. So using this, they form a linear pair. That means that ABC, this angle, is equal to CBD, this angle. Well, right there, I just drew one that is not true. So if you remember, linear pairs add up to 180, right? So that means this angle could be 100, and that means this angle could be 80. That is a linear pair that does not add up, or that is not equal. Let's find another counterexample here. All right, angle 1 and angle 2 are adjacent angles. So remember, that just is two angles that are next to each other. So I'm going to draw my two angles. So that's angle 1 And that is angle 2. They form a linear pair. Well, right here I just drew two angles that are adjacent. They're right next to each other. And angle 1 and angle 2 do not form a linear pair. So what we could say is we could say angle 1 is equal to, I don't know, say 50 degrees. And we could say that angle 2 is equal to, 30 degrees. Angle 1 plus angle 2 do not equal 180 degrees. Brilliant. All right, let's go on to example. This says 7, but we all know that means 3. Okay, we are going to decide whether it is inductive or deductive reasoning to reach the conclusion, and we're going to explain why. So remember, inductive is using patterns. Deductive is using laws and facts, right? So let's see what we can get here. So this first one is saying that each time Monica kicks the ball up in the air, it returns to the ground. So the next time she kicks the ball up in the air, it will come back down to the ground. So here she's using this pattern, right? She kicks the ball up, it comes down. Kicks the ball up, it comes down. There's no facts here, there's no laws, no definition, so this one is going to be inductive reasoning. And that's because she is using a pattern. All right, let's try this next one. All reptiles are cold-blooded. Parrots are not cold-blooded. That means Sue's pet parrot is not a reptile. This one is going to be deductive reasoning. That is because she's using facts. For example, that all reptiles are cold-blooded. That is a fact that is proven. Because she used that fact to then apply it to her parrot, that is going to be deductive reasoning. That is the end for Chapter 2 notes, or 2.2 notes. If you've got any questions, we'll go over it in class. And if you've got any other issues, just email me and go ahead and do the assignment listed above.